I hope no one is tired already after a few talks. Um, so you will be fully concentrated on my presentation as well. All right, then let's start with the less important stuff like introduction. So the topic of my talk today is about complex UI state management. And the state management is really what we do in all front-end applications, because without that, it will be very, very hard to do anything, um, unless it is a very static app. But still, we probably need state management in applications. And in theory, it sounds very simple. In practice, it is really not. And I will show you why it is not and what can we do about it. So a little about me at first. I'm Tomek. I'm engineering manager at Fandom. I'm right now working on creator tooling for moderators and administrators on our platform. And thanks to that, they are able to create those fantastic communities. I really encourage you to visit one of them. Maybe you already did. It is really fantastic. And the very important thing here is that I have front-end engineering background, and this allows me to tell about this kind of a topic. If I didn't have this background, I wouldn't be able to talk about it. At least I wouldn't be confident enough. So the goal of this talk today, you might wonder, what is that? Is it about talking about new fantastic framework? Well, hopefully it is not about talking about fantastic new framework. Maybe it is about new idea. Maybe it is like fresh idea that will change your entire worldview, how to create applications in front end. Well, it is not. Um, my goal for today is to introduce you to an idea of state machines. And this is an approach that will allow you to improve your code, your code maintainability. So it's very, very useful to know about this approach, even if you are not going to use it. Uh, just knowing about it is very, very useful. So the plan, I will first start with talking about the current approach, how we approach state management in current not React, JavaScript applications. I will talk a bit about single store approach. This is very popular in React, I think, mostly, but not only. Then we'll proceed to talking about what is really a state machine, what is the idea behind it, and why do we even care about that. And then I will show you, actually, I will kind of show you the new cool framework. It is an XState, and you will see that it might actually solve your problems. Before we start, I would like to note that I'm gonna use React point of view because I'm the most experienced in React, and I feel confident in that technology. But it's very simple to read, and you don't really need to understand what's happening underneath. You kind of you'll have to have an idea what is it on the screen. I'll also try to explain it as best as I can. But if there are any questions, please ask it on the chat. I'm going to explain everything if there's a need for that. I'm also assuming you know a little about frontend, although it is not required. This point is not required. You might even find yourself using some of my points in your later work, even without working on frontend. So please stay in the room. So the modern front-end applications really use different libraries to handle UI state management. This is just true, right? There are many libraries to handle state management, but the important thing is that we need that kind of libraries. We need some kind of an idea, some kind of an approach to manage the state. And I'm going to use this example throughout this presentation, so it's very important to understand what is going on here. I'm going to implement a state management for this kind of component. It is an input that lets you write a full name the minimum text length is 3 characters, so there will be like error state with like red border, maybe red text as well, if it's too short. If it's longer than 3 characters, then it's valid. We will consider it valid. Then we have a save button. The save button will, we can imagine it, just clicking on it will cause this whole component to lock itself. It'll be in a loading state, kind of like loading state, and we can imagine it'll send some data to the server, and then we'll get the response from the server, and it'll be saved on the backend. We have also the clear button function, which what it really does, it just clears the input. We also have the lock button, which might not seem very useful. Maybe it is not, but you can just lock the input so it is disabled, and you won't be able to edit the text. It might be maybe useful if you want to be sure that nobody will change the value if it's like the shared application. So yeah, so this is basically it, and it's seemingly simple UI really, but in fact it is not that simple to implement, because there are many states, and each state will have different rules. So maybe the button will be in a loading state, maybe there will be a clear and lock disabled. Maybe if you're in a locked state, you will have to disable the clear button, but you still can save the value. Also, the input has to be disabled. And then again, there is like error state. What should happen if it's empty? Should it be should we have an option to clear the button? Should we allow it to the user? When you start to implement this kind of UI, you will notice that it is not that easy to implement, even though conceptually is very simple. And how we do it today, how we do it nowadays in React or non-React applications, we often go to the unidirectional flow model, which is basically that. It means that we have a state and we keep data in the state. So we can imagine the name, the value of an input will be a kind of data that we'll have to keep it in a state. Then the state will produce a view. So the application will know that in this input, there should be this value. And whenever we want to change anything, we have to perform an action. An action is an only way to change the state. Without an action, we can't really do it. And then again, the action will produce a new state, and the new state will produce a view. And this is very nice circle. It's very easy to understand. This flow is very easy to understand, which is the main benefit of that. And it works quite well in your application. If you are using the, I don't know, Redux, let's say, you will be very familiar with that. So the universal model for the state generation is really state, and an action produces new state. This is very common throughout different state management libraries. It's not only it's not only useful for the unidirectional model, it's also useful for other models as well. And in the React world, the Redux is king, really. I think you will see it the most. It will be used the most of the time. And I'll kind of compare my approach to this framework, because it seems the most useful probably for most of you. And I'll show you also that it can be, some things can be done better. There are also some alternatives like Sustand, Recall, Jotai, however you actually read it. But these are, in idea, quite similar to Redux. They don't have a single store. They are working on atoms or on some other words that this library authors use, but it is a still unidirectional model. So you will perform actions to change the state, and state will produce a view. So you can also go with custom solutions, like just using the use state, use Reducer, use whatever your framework provides to handle the state. And you can just use that. It's perfectly fine. If you have a need for that, then sure. Quick reminder how Redux works for those of you who don't know. There are very simple concepts, so I'll go quickly through that. First of all, we have reducers. Reducers is are really a function. Is a really a function that, based on a state and an action, will produce a new state. So as you can see here, this counter reducer is a simple function that will, based on the action type, either increment or decrement, will add or subtract one from the state value, and that's just it. There's nothing more to it. To use the Redux in React applications, you'll have to first configure the store using simple API, and then you will put it in a provider, which, if you don't know how provider works, is basically it'll allow you to read the data, read the store, read the state from whatever point, from whatever place in your application. So it's accessible from wherever you really need it. And then if you want to use it, you will probably go to the hook API. If you select it, you will get the state using this hook. You can then just show it, and the component will automatically re-render. It'll automatically render based on if there's anything, if anything changes in the state. But if you want to change something, you will go to the dispatcher. You will use dispatch, and then you can you can just change the state by dispatching an action, either increment or decrement in this case, but it can be whatever. You can also put a payload in there if you wish. So this is basically how Redux works, and I think it'll be enough to understand the rest of the talk. So Redux promotes single data source. It's actually the required point in the documentation that you have to have a single data source. If not, if you have like multiple Redux sources, they won't be able to communicate with each other. So you have to have a single data source. It's very easy to understand. So that is the big benefit of that, because you can jump straight into coding. You don't have to think too much about it. Although that might be a con as well, which I will mention later. It is not ideal. After some time, you will notice that your code becomes hard to maintain. I mean, it probably depends on the case you have, and depends on your engineers, on how much time you have for the refactor. But in most of the cases, you will find yourself in a place that is very hard to change anything to. Maybe not really hard, but it will be quite difficult to change something in your code, in your state management. So the mental model, in my opinion, is too simple for some of the problems. It is not too simple for all of the problems. There's also an important thing I want to mention. It's something to remember that the Redux is perfectly fine. It might be even the perfect solution for some of the problems. I'm just feeling that for some of the issues, it is not ideal. And let's go back to our example. If we want to disable clear function, meaning if the input is disabled, if it's locked, how do we even want to do that? How do we even approach this in Redux? Well, we can kind of do this in a view before dispatching an action. We can check for this, but there is a problem, as you might imagine. If you use this action multiple times, you will have to copy this code multiple times, and it's really not ideal. It will be very hard to maintain, like very quickly. I can assure you, it is going to be very tricky to maintain. So here you have this is locked and dispatch, and then you'll check for this is locked and dispatch if it is not locked. So it is really hard. Maybe you can put this if condition in the reducer. It'll be much better. I can tell you right away. It will be much better. But maybe this example is not a perfect way to visualize my point. But after some time, after a few conditions, after different logic, you will find that your reducers, your action handlers, will be very convoluted. So again, it will become hard to maintain. So yeah, again, in the reducer, you will check for the state locked or blocked, and if it's blocked, then you'll just return the previous state, and if not, you will create the value. And putting if conditions for every action, it really becomes an issue, especially in large projects. So we want to kind of solve this issue And how do we do that? Like, we could use some help, right? How to write more maintainable code? Let's focus on the model I introduced before, meaning the unidirectional flow model, whereas we always have a state, view, and actions, where actions produce a new state. And I would focus on this part, on the state. Maybe we could do something about that. What if we just divided the state into like substates or like smaller states, and in each state will be able only to change or to only perform some kind of like some subset of actions if it's in given state. So like in active state, you won't be able you'll be able to actually change an input, change the value, but in a locked state, you only way out, let's say, like this diagram is not perfect, it's not logically correct, but in locked state, you can imagine you can't do anything aside from unlocking it. Maybe you can save, but aside from that, you can not do anything. And what's that? Like, it's basically state machines. That's almost all everything you kind of need to know at first. And why is it really better? In my opinion, it gives us more tools to define state and to handle the states, to manage this this in a code. And are there any tools for that then? I mean, we can still use Redux. It's just a matter of how you model the state. Because if you model it correctly, you will have a state machine in Redux, so you don't really need a different library. It's even what documentation says in Redux, like treat reducers as state machines. It is strongly recommended. So authors of this library will strongly encourage you to model your state in a way that there are only few ways of performing an action in given state. So we should treat reducers as state machines whenever you can. But there's another option, and this is the main point of my talk, meaning I would like you to introduce you to the XState library. XState library is a tool that allows you to model your application state using state machines. And the XState is really like an extension kind of Redux, because you can actually do the same things as in Redux, but you are given more tools, so you can be more restrictive about some things. You can perform more actions. You can just basically model it a bit better, in my opinion. Again, for some cases, it'll not be ideal for your every problem. And going back to our example, when we had this input with 3 buttons that are different states, we can actually model it using the state machines, and this is how it's going to look. This visualization is going to load. Yeah, it's already loaded. It's actually the tool that the XState library maintainers provide. So you can just input the code. You will see the code in a minute, and you can produce this kind of chart, which, in my opinion, is very helpful to share with other developers or the engineers. You can even share it with, I don't know, maybe your designer that will be probably grateful if you describe the logic of the component for them in a more graphical way. So you have that. You can actually click on it as well. So you can see if you toggle lock being in a valid state, you'll be in a locked state. So you cannot do anything aside from toggling lock back again. And if you want to save, maybe you'll go into loading state, and the loading state will basically wait for a response from server, and it can be either correct answer, like you'll save it, or there will be an error. So you can handle this error or the correct state. In this case, you'll just add an error to the context. I'll talk about what is a context in a bit later, but you will also go to the valid state, and you can nicely visualize your state machines. So it's very, very useful. And I'll show you just how the code looks. So this is how the code looks like. This library is using the object configuration model, which is really you put everything in an object. For some of you, it might be useful. There's one con for that. It's very hard after some time if you have multiple indentations to it'll be quite difficult to see a difference between like in a Git. So yeah, that's maybe a minus, but other than that, it's very, very helpful to visualize. Even in code, it looks quite readable. So you have your create machine, which is the main API, and then you will define your states, either valid, invalid, and in these states, you can do different things. Also, you have to set an initial state first, so your machine will know where to start. And if you're in a valid state, you have like three options, either to perform an action toggle lock, which will get you to the lock state. You can maybe go to the save, which will toggle loading state. And you can also change value, which here you can also define a conditional transitions. Using this kind of conditions, you can either go to the one state or another. Like I showed in a slide before, it's also nice to visualize. So this is how it goes. And I'll have to introduce some new phrases because this library uses very specific nomenclature. So state machines is really a mathematical model of computation, but I already explained it how it looks. It's this maybe this description doesn't really help with anything, but it's very old idea. If you studied computer science or any other engineering topic, you would probably be familiar with state machines. Like mealy and more state machines, you probably probably know about that. And state charts, this is what is used for the XState library. It's kind of like an extension of state machines, because state machines in itself, it's a very simple, very, very, very small idea. But then for the real applications, you will need some new tools to define it better. And state charts is like it's a visual extension, because it's also a visual representation, like a formal notation of defining state machines. But and there are some concepts like context or nested states, which I'll like. Context is basically an extended state. In context, you can think of it like a container for your data. You'll put the data there, and this is how you actually access the data. Like the value will be in a context. Whatever you'll put there, it's basically a container for data. Events. There is a slight difference between Redux and XState, because what you think about when you're thinking about actions in Redux, the equivalent of that is events. So an event will be performed from a UI, and action is actually find and forget effect that will happen inside a machine. So like assigning something to a context will be an action. Spawning a new machine will be an action. Sending some data, sending some event to another machine will be an action. But if you are talking about something that happens on a UI, it'll be an event. And an actor model. This is also very nice, because this is a simple model, the simple idea that everything in a system is an actor, which really has like an actor is an entity that can communicate with other actors by sending events, receiving events, and each actor can change its internal state. So there is no possibility for other actor to change other actors' internal state without calling an explicit action. So this is also worth mentioning, and this is also very, very old model. Maybe not very old, but it is quite dated now, and you might be familiar with it from other languages. And XState is not just a library; it's also kind of an ecosystem. It gives you a visualizer editor, like the book dev tools, so you can use it. Like like working on a real applications. You can plug it in your Chrome dev tools, and you can nicely visualize what's happening in your machine. But you can also visualize, like I did before, your machine. So maybe you can share it with your designers, your product managers, or your colleagues from the team. There is also a graphical editor, which was released recently, I think last month. So you can build machines without even writing a code. That might be also useful for you. And a strong path for this library, it is already mature. There is a community around it. There is a tooling around it. There's some libraries, tutorials, courses online. It's very easy to get in. in XState. There are many resources you can use to learn this library. And XState this is very important to me because this library understands and uses concepts that are very well researched. I'm talking about state machines, I'm talking about an actor model. And the benefit of that is not only because you can just link to this nice paper that was released in 1960s, you can actually reuse some approaches, some algorithms, some patterns connected with these ideas. So you might see if you snoop around GitHub repository for XState that there is an RFC mentioning receptionist pattern, which is a pattern from an actor model. And because XState uses actor model, you can benefit from using approaches that are already defined, and this is very useful. It also applies to the state chart XML standard notation. So even if you are not using XState, you might actually use other library that will also be compatible with the SCXML format, so you can export your machine to other systems as well. It works with different frameworks. So if you learn XState, you probably can bring it to Vue, you can bring it to Angular, you can bring it to Svelte. With any major framework, you can just use it there. So that is also very useful. It's not just this is also very important. It's not just global state solution replacement. It's not like you can just have one machine at the top and that's it. It can be as local as you need. I will show you an example later, but what I mean by that is that you can use your machines like just for a single component in your application. So it doesn't have to be like global state only. You can just plug it in a single component. And sometimes some components are quite convoluted, quite their logic is quite not as simple as you wanted. And you can use it there. And this is what we do at Fandom as well. And it's very much testable because of these APIs, this approach that it is not only like a React tool. You don't have to plug it into you don't have to plug it into a React component and test it as a React component. You can just test it as is. You can just test the interactions. You can test how your machine reacts on events. And I asked my colleague today or yesterday about that, and he told me that he didn't have to even mock this. He didn't even have to mock the code, which is very useful. If you are familiar with testing, you know that mocking is very dangerous sometimes. And the single most important thing is it changes how you think about problems. And what I mean by that is in Redux, it's really simple to start coding right away. Like I mentioned before, you're kind of encouraged to do so. And in XState, it's very difficult to actually code right away, which you might think it's not really a pro. It's not really a benefit. It's kind of like a disadvantage. But after some time, you will figure out that by kind of forcing you into modeling state first, like with pen and paper, you will think about problems better, in my opinion, because you will be able to maybe recognize some issues at the beginning. You will, of course, recognize some issues later while you're coding, but you can still change it. But you will just have a full view of how the system should look like and how it should work, which, in my opinion, is invaluable. This is something you can just benefit from that. And the most important features of XState, in my opinion, an XState provides you, it can allow you to do a nesting states. So like you see here in the code, you have two states locked and active for this only example, and an active state will have this field. Again, you can define states. So it's like state in state. So it's a nested state. So you can define a valid and invalid state here. And this is useful because maybe in sometimes you would like to define that only in this state there's this nested states possible, and in any other state this is not possible. It is very nice way to model your application logic. And this is you have to basically, if you want to have a nicely maintainable machines, you're probably gonna use it. Then again, another type of state, there is a parallel state. In order to actually define it, you will have to add this type parallel. And if you define it that way, the states in your state will start behaving quite differently, because there's a validation and autocomplete state here, and they are working in parallel. So they are not dependent on each other. So they'll happen at the same time, which is very useful. Like we can imagine in the case of our component, we might have to add a function for autocomplete. And this will be how you would probably do it. So you will define a second parallel state, and in this state you can either open the drop-down menu for this suggestions. You will have some loading from the backend from suggestions, and then you will close it, and it all will happen in the same time as a validation step, because at the same time the component might be valid and invalid. It's a very nice way. And this is a visualization of both parallel and nested states with this tool I showed you already. So you have this autocomplete state here. You have also your validation, and they're living at the same time. They're basically at the same time. So if you perform an action here, you can toggle autocomplete. Maybe if it's an error, so you will go back to the closed state if it's an error. You might want to file silently. But if there is some data, you will have it in an open state, and you can just then close it. You probably will implement like picking a suggestion, which will be a different action, but this machine is not complete. And this is a very nice way of showing it. And the third most important thing, in my opinion, in XState is an actor model. You will use it all the time if you start using XState. And it's really useful because it allows you to communicate between machines, to divide your logic into smaller pieces. Like in this example, you can import an autocomplete machine here. You will put it in a context. You will just like put a reference handler for it in a context so we can use later. And then maybe in an active state, on a toggle autocomplete action, you will actually spawn an autocomplete machine. So you will spawn different machines. So you don't have to put this logic in this input machine. You can extract it to another machine. So you can toggle it here. And on other action like change value, you can actually send the event to your child machine, so it'll know that something has changed, and maybe it has to reload some new suggestions, which is also very useful. And this is the three most important things in XState. How do you even start using it in real applications, you might wonder? Well, it's a pure JavaScript library, so you can use it without any other framework, and this is how it goes. You will create a machine, and the machine itself, it's not really a walking machine at the point of definition or declaration. You'll find out that it is really more of a blueprint, a template. So in order to start using it, you have to interpret this machine, which is also nice because you can interpret it like multiple times for different applications, and the state will be local for each machine, for each service here. And then you have to start it, and if it's started, then you can start start sending events. Reading data, reacting to it, maybe performing other actions. You can start using it. You can also stop it. So you can maybe restart it later, or just stop it for the rest of your application. In React, it is also very simple because it comes with a different library, XState React. You will import your machine, use machine hook. This is the first hook you will use. It is the most important for like doing this local machines, like for the input that doesn't have to be a global state thing. So you will use this hook, you will pass as a first parameter your machine, your blueprint here, and then it will start your machine. You will get access to a state and a send fields, so we can either send an event or read the state. You can also provide an initial context here. That is also really useful. And then you have three other hooks: use interpret, use select, and use actor. And this is how you probably will use the most often if you want to replace Redux. First of all, you will import all the hooks you need. I forgot about use actor, but we don't mind that. And let's say we want to mimic the Redux single store. Maybe you want to have a single machine at the top so you can access it whenever you want. You would use this interpret hook. So it'll actually it'll create an instance of your machine, but it'll be started, but the service itself, the service variable, will be a static reference to that. So whenever the machine changes its state, this component won't re-render, which is very useful if you want to use it at the top of the application, because we don't want to render application each time we render the new store. So this is very useful, and you can maybe use a provider for this. You can use your context. You will provide this value of service, and if you want to use it later, you can then get it from context and use this useSelector API, which you pass the service as a first argument, then you'll define the selector here as a second argument. This is very similar to the Redux, so you'll be familiar with that if you're using Redux already. And then this is how you basically use it. You have to read it from context. And nice thing is, it'll only re-render if the count value in the context changes. It won't re-render if just the whole state changes. It'll just take a look at the count value. Also, there is a use actor hook, which will allow you to send new events, and it'll also react to any state changes, which might be useful in some cases. You can also read the if the state is invalid or valid, so you can put a style on your component. And this is how you use it. You can send events like that, like in an on-click handler here. You can just send add event, and that's it. And then your machine will react to it. If it's in a state that won't react to this event, nothing will happen, which is also very nice. And yeah, this is about it, how you use it. And I want to share you a bit of a story from Fandom, because I'm not just talking about it because I just read about it yesterday, and I think it is useful. We actually used it in a real production application in Fandom. To give you a bit of a context, this year we were working on an interactive maps project. This basically allows you to create your own maps on our Fandom platform. You can put the markers in there. You can put some description in each marker. You will have a full creator experience without having to write a code to define this map, which is also very nice. And for this creator, we used an X state because we thought that there is a possibility that we will benefit from having state machines in its creator. We worked in a small team of full stack engineers. This is important because some of them were more backend focused. So we managed to work in this kind of a setup, which turned out really well. And this is how it looks like. If you go to this, if you are a user on Fandom, you can go to this any community. You can enter the map creator, and here it is how it looks. There are like categories on the left. You can add new categories. You can reorder the categories. You can turn on grouping markers. There are many interactions here, because the left side of this creator will have to, like anything that happens at the left side must be visualized on the right side, the preview. So there is this communication between, and this is how we actually implemented it. We are spawning different machines, and we are communicating them using this APIs that XState provides. And we have some learnings from that project. It was not ideal, but still we managed to do it, and it works really well. So about the pros, we were able to switch after some time, because at first it was quite difficult to actually switch to this model of thinking, because we were stuck with the Redux. I was also stuck with that. So it was quite a difficult, the learning curve in XState is quite steep, but I think it's still worth learning it. We managed to locally define state for a few components, and thanks to that, we don't have to worry about performance issues with like reloading whole application, because something at the top of the application has changed. This is also really nice. And extending the code feels more robust. I have a story. Like a few weeks ago, we had a hackathon, and we wanted to extend the map's features. Like, I don't know what it was about. I can't remember actually right now, but we actually extended the map creator features so it can do something more. And I think by using XState and how we modeled our state, we are able to get some features like discarding changes and saving like automatically. It all happened automatically without even caring about it. So that was really nice. The cons of XState and how our approach really, not of XState, but we are still partially stuck with the Redux mindset, like I mentioned before. So at the beginning, we started with the single machine at the top with, I think, only 2 states or one state. So it really was a Redux, but with a different library. So there was no much benefit from having an X state. It was just a bit harder actually at this time. So it was really hard to adjust at the beginning. We were able to switch again, but it was really hard to adjust at the beginning. And if you're using TypeScript, this really saddens me that there are some issues with TypeScript. Maybe in the future, they'll improve it. They actually are working on a new version of XState that has to improve the TypeScript experience, but in some cases, it is not very simple to define your state machine and to have it working in a TypeScript-friendly way. So these are our learnings. And the important thing is we know what to improve, and we have a plan for that. And we'll continue exploring this library. Right now, we don't have any plans to expand it for all applications because, like I mentioned before, it is not holy grail that you will use every time you have a state management library need. You'll just use it for particular cases, for particular needs. And how to learn more? I think the best introduction to XState is the documentation itself. It's very nicely explained, some visual aids, some concept explained as a simple models. There is also an Egghead IO. I think it's free, maybe not, but there is an introduction to state machines using XState course, which is very well prepared. I also encourage you to do that if you prefer learning that way. If you want to know a bit more about specifics, why some maybe things are named in a way they are in XState, you can go to the statecharts.dev website, which is a formal definition of state charts. So, like I mentioned before, it's kind of an extension for an XState. And again, things to keep in mind: it is not really a solution to every problem. This was not my intention at the beginning of preparing this talk, that I want to convert all of you into this XState library. It is not really useful. In some places, you would use like Redux Toolkit, which is also very nice. You will use maybe Zustan because you don't have to do so much state management in the library, and you don't want to have this big piece of code to actually support your state management. And again, if you're really caring about TypeScript support and you feel that you have to have it perfect, the TypeScript support is not ideal yet. Maybe in the future it'll improve. Hopefully it will, because I will be very sad about it if it won't. But it is something to think about. And we don't have much time. I think we have only 1 minute. So I would like to invite you to joining Fandom, because we are looking for many, many talented engineers, either senior or regular. You can visit our booth, our virtual booth, to talk with Ola about that, about Fandom, what we do as a company. You can also contact Eva Nowakowska on LinkedIn. She will be very glad to talk with all of you and respond to all of your questions. I'm sure of that. And in case you want to stay for a bit longer, are there any questions? I don't see anything in the chat. If not, feel free to reach out to me either today, like in person on the party, or just wonder about TypeScript issues. So the TypeScript issues are basically about not being able to model something, or not having this feeling of safety in some places, because maybe in some state the context will have a particular shape, meaning maybe in a if you are in a state of having this input invalid, there will be an error in a context that is defined. So you can define it kind of that way, but it won't work well in TypeScript, in my opinion. So there are some issues with that. Actually, the Xstate maintainers released an extension to Visual Studio Code that helps you to generate this schema on the go by using the code generation, TypeScript definitions, code generation, and it may be useful, but it's very slow from our experience, so it's not ideal. So I hope it answers your question, Agata. So feel free again to reach out to me in a chat, in a message. You can write to me. I will share you the link maybe on a chat to this presentation, because it is publicly available. So you can open the links I mentioned today, because links are not really useful if you're not clicking on them. So I sent you on a chat this this link to my presentation. You can go there, you can take a look, you can click on the links, and again, feel free to reach out to me. Thank you again for participating, and I hope you learned something. Thank you.